Okay, hello everyone. Yeah, so well done. Fifth talk in a row. So let's get some more participation. Put your hand up if you've heard of JavaScript. Yeah. Oh, quite good. Okay, and okay. Put your hand up if you've heard of Gleam. Okay, so most of you know that's around. So yeah, so I'm Peter. I'm crowd hailer on the internet. I'm currently between jobs, is what we're saying here. And yeah, this is Gleam. So Gleam is a friendly language built for type-safe systems at scale. This is just a screenshot of the homepage from yesterday, because that's when I made my slides. And we go over here, and we have, this is the homepage of Erlang. A fun fact about this, they ship you different code snippets on how wide your screen is, and I liked this one. But yeah, so this says, this says functional programming for the parallel world. And so just kind of diffing these, this is what I've summarized it to you for. All right. So yeah, so we like functional, we like parallel. So for people outside this room, it's worth talking about those. But for people inside this room, it's really all about that point at the top. So I asked ChatGPT, what's the point of a type system? And it did a pretty good, thank you, pretty good, I was happy with this summary. So early error detection, I think we can agree that's worth having. The last talk has said we like it. There's hours to be saved. But let's kind of like work our way through some of these. So we'll come back to this, so I won't read them all out. Right, let's go this way. So in Gleam, so this is our first bit of Gleam code. I'm not going to explain everything as I go along, but we'll try and make sure I don't leave you too far behind. So this is a function, and it's the same function. So in the top example, we have type annotations. So, you know, type annotations, you know them from like Java if you've played in that space. It's same as a dialyzer spec. You know, we have here a function takes a list of integers. We're going to fold over this list of integers and add them together as you go along. So add is a two-arity function, and list.fold expects a two-arity function at the end. And then below, we have exactly the same code without the annotations. So the reason this is interesting is because I think we can get rid of these 2 points. If you get rid of all your type annotations, it's not helping readability, but it's also not making the boilerplate any worse. So that's not an interesting point necessarily. One other thing about Gleam. So Gleam transpiles to Erlang. So if you have this function, you end up with Erlang source. You can also end up with JavaScript source. So if you weren't sure what the first one was doing, you can look at it in your language of choice, which I guess I know for most of you. So the fact that it transpiles means there's no performance benefit to be had. You know, if the Erlang compiler can do it, the type system doesn't make it any. All the type information is lost. But the other side of this is the compilation overhead is pretty small, because when compiling a Gleam project, the vast majority of the time is spent in the Erlang compiler, because it does most of the work. So again, let's get rid of those pros and cons. OK, error detection. So this is the classic. So here we have a bit more syntax. So Gleam has sort of custom types. So this is a combination of a record and a union. This is how you'd represent your Erlang OK error tuple. So here we have some code where we've got hold of one of these results, and we're going to return a string, but we've forgotten to handle the error case. OK, so Gleam catches this. And in fact, Gleam is sound at this point, so it has exhaustiveness checking. If you use patterns, pattern matching, or guard clauses in your case statements, they're all supported. They're all part of the exhaustiveness checking. So this was the longest feature to get ready for 1.0. But it means that if your program compiles, it won't crash. So that sounds nice to have. So chatting a bit more about error detection. Gleam has assertions. So if you really know that something should be OK, or you don't care about it, you can assert that it is OK. And it also has a panic. So these are kind of doing the same thing. We've just been more verbose in the second case and put our own panic message. So if your program compiles, it can totally crash. And the best way to deal with this is a supervision tree. If your assumptions are not true, if your assumption about the assert or the panic has not been the case, then you get a sort of fallback to the Erlang primitives. So these two can work together. But I mean, I would say that you know, Erlang can make very reliable systems. So as much as we do like early error detection, it definitely does exist. It's not yet the killer feature. But I'm also going to remove this con of rigidity to consistency. So you have to use an OK or an error value with a value or a reason. You can't just return the bare error atom. Gleam gets rid of these things for you unless you define custom types for them. OK. So cracking on. Steep learning curve. This is always a fun one with functional programming. Yeah, one person loves it, so that's good. I wonder which one. My favorite one, I suspect, there's screens everywhere. My favorite one is this one. Gleam is a pure Muggle language, no trace of magic to be found. This really speaks to me. This is actually, I think, a very similar kind of pitch to Erlang itself. So I think that's quite good. I suspect the last one is not really readable, so we can have this. The design of this language is frigging awesome. I'm only a newbie, but the ability to pull Erlang standard library and use functions from Erlang code I wrote previously has me gobsmacked. Nothing should be this easy. Which I disagree with the last point. It's fine that it's this easy. We're OK with that, yeah. So let's get rid of these complexity and steep learning curve cons. So we now have no cons left at all. So yeah, maybe we should just stop there. Thank you. Yeah. Cool. Right. So now we're going to talk about something else. OK. So who knows this table? Who's seen this before? This is a thing we like to have. This is a good Erlang sort of classic. This comes from, I think, Sashi Urich's book. I hope it is. I should have written that down if I was going to say it out loud. Comparing two services. And the punchline is Erlang does a lot of things that in other ecosystems you'd have to reach for external tools. So here we go. You've got long-running requests. I don't know why you'd use Go and Rails together, but it's an option. Don't use MongoDB, period, etc. But a Bash script is going to show up. Bash scripts are going to show up everywhere. So let's investigate this some more. So what about CI? Okay. So CI is a thing we do more now. So you have more kind of like hosted tooling, you probably work in GitHub. CI is becoming a big YAML mess. Even when I work in Erlang, it's still possible I have to deal with it. So this is Dagger. This is a way to turn your CI into code. So you can commit it, you can diff it. And it supports TypeScript, Python, and Go. So, OK, we'll move on. So then what about where you're configuring your infrastructure? So this is a kind of trend where instead of Terraform. So I suppose the last one was more a comparison to Docker files. This is probably the better analogy to Terraform. So yeah, we're going to spin up our infrastructure. We want to do this as code because that's best. And we can do it in, all of the, OK. Similar, the same selection of languages, TypeScript and stuff again. So we can't write everything in Erlang. So if we expand this table, what I've expanded this to say is like most of the projects we write now, they're not just servers. So that's what I've done here. So we're still Erlang champions, but we've got a front end. Okay, there's going to be a dashboard internally. There's probably going to be a user interface. Like, unless we're doing telephony, it's probably a front end, and even then, there's probably an internal dashboard. So yeah, Project A just cracks out some JavaScript. We're a bit more like, no, I don't want to. So we can use live view, unless it needs to be offline, and then I guess we use JavaScript. Native app. To be fair, I did ask around what people might use for this. And someone shared me a project. I don't remember the name of the project, but they were like, oh, you could use such and such. You just have to write the Erlang bindings for it. So that was the first suggestion I got, was a thing that you could write the bindings for. And then, so the bottom two are the kind of infrastructure as code and CI pipeline as code that I just talked about. So, OK. Why is this interesting? So Gleam is multilingual. So this is a quote from the homepage. So Gleam makes it easy to use code written in other BEAM languages, such as Erlang and Elixir. Great. Gleam can additionally compile to JavaScript. So this seems a bit weird to begin with, but enables you to run your code in other places. So, OK, we're now multilingual. So this is turning into a bit more of a trick. And we can now replace this table like this. So we don't disagree that Erlang and BEAM is great for all of these things. It's just, you know what? There's a bunch of off-the-shelf edge workloads. I want to use some Cloudflare workers natively. Let's just compile a Lambda function in JavaScript and not get complicated. OK, great. So let's talk about what this looks like. So here's a bit more Gleam code. This is essentially the most complicated feature in Gleam. So for those of you who haven't seen Gleam, I will try and explain what's going on here. So if you have a result type, it's either it's an OK or an error. And you often want to do something with that only if you have a value. And you return early if you have an error. So this is called railway programming. Here you have this try function. So if we go to the bottom, here's the implementation of try. Okay, so if it's OK, pass it to the function. Otherwise, if it's an error, just return the error. And you can use this with an explicit callback. So you take 2 arguments. The first thing is your result. So here we're using HTTPC to send a request. It's going to return a result of a response, because there may be a network error. And we just want to get the body. What Gleam allows you to do is we have this special use syntax. So use syntax, it's called like backpassing. It takes the rest of the body of the function. So from here, the second line, the OK response body, is essentially syntactic sugar for a function which has 1 argument, which is the response, which is passed as the second thing to result.try. So the key thing to notice here is result.try only takes 1 argument. Okay? I see some vague nodding, but yeah, ask me about this afterwards if it doesn't make sense, but we're going to assume that this is good. And so how do we make an HTTP request? So here we have HTTPC, which is your built-in BEAM client library. You have the HTTP request and response. So they actually come from different packages. There's a standard definition of the types. And then we have the Gleam result module, which allows us to work with these results. So here we go. Here we make a request. We're going to get example.com. Here we assert, because we know that the string is a valid URL. We're not passing in a dynamic value. So let's just assert that we get a request. If we're wrong, or if anyone changes this, it'll panic and we fall back, as mentioned before. But here we go. We send the request. We get maybe a response, if it was OK, and then we do something with it. It's OK. This is good. But this is using Erlang's built-in HTTPC. So what does the code look like if we want to go to the browser, if we want to use this JavaScript environment? OK. So it looks very similar. The key differences are, well, the key similarity is we've used the same request and response type. So if we have any code or logic for making these requests and response, we can send them from both environments. What we have changed is we're using fetch, which is the browser native API for sending requests. It's also available in Node. And we've also got this library called JavaScript promise. So when we send a request here, we no longer use result.try. We use promise try await. This is another function which we're using the use syntax. So we say, OK, when this promise resolves, because fetch.send returns a promise of a result, when the promise resolves with an OK value, call the rest of the function, otherwise return. This composes, so the fetch API returns a response with actually essentially another promise to the body. So you have to explicitly read the text body, which is asynchronous again, so you end up with another promise. These compose nicely, but it does mean that at the end of your function, you have to return something that matches the type. So you need to return a promise which has an OK value in it, because otherwise your whole function wouldn't be returning the same thing. So OK, so there's differences between these. You can't immediately copy the code from one to the other, but it's definitely recognizable. And this is where we kind of loop back around to the types as a design tool situation. This is a browser, and this is a server center. Good. But obviously, in the browser, we don't have a pool of processes. Like, making these requests is not cheap. If we were to try and make a blocking API, we would block the UI. So the actual environment that we work in, there's a lot in the browser now, but the kind of primitives of the environment is a single loop, a single event loop, and the need to keep the API, the UI responsive. So in this environment, awaiting something needs to explicitly exist. On the back end, we can spin up a process per request. The request is come asynchronously from the outside world. It's much simpler to just deal with things synchronously. So now we've got a way where Gleam doesn't actually have blocking or non-blocking I/O. It has libraries which expose in a type whether they are blocking or non-blocking I/O. So like, you can just kind of crack on. And if you forget something about the environment you're working in, the type system will tell you, because you'll get an error if you use result.try with the fetch. So like, what other things do we have? So what about some serious code? So here we have how we start an actor. So Gleam has an implementation of OTP. This is a re-implementation, so it makes certain things easier to type, but it essentially worked on the same design principles. And here we import Gleam OTP actor. So the key thing about OTP is it's not available by default. We make it a library dependency, we pull it in, and we start, and then we crack on using OTP, we all know and love. So this is, I probably should talk through the code some more, but yeah, we have a handle function, which we pass when we start an actor. The handle function takes message and state. The type system makes sure that the message you send to this PID matches the message type that's called in the handle function. Your PID reference is parameterized over the type of the message that it receives. So you can't send a message of the wrong type to a process if you stay in the Gleam language. You can if you FFI out to other things, but then you've made your own rules. OK, so how do we run OTP in the browser? Well, you can't. And again, this is what happens if you try and run Gleam with the target JavaScript with the code we just have. The type system goes, you're using a feature that you can't have. And so now you end up with a situation where your type system and your build tools, they know where you can run your code. And this incentivizes you to kind of write libraries in a way that they can be used in both places. Because if you have code that doesn't involve promises or OTP, for example, a function to just make a request, like you might have in a client library, you can ship that, and it can be used in both platforms or between your front and your back end. But when you come to actually sending them, you have to bring your own HTTP client. And to begin with, this sounds like extra work, but it has a lot of benefits, because if you have like a constrained pool, or you want to do some configuration in your client library, or like have a certain number of connections or something else, it gives you the same control. So this kind of, I don't know, this forced separation, I think, is probably another one of those ones where some people would see rigidity, and I would see consistency. Cool, so that's where we do that. OK, so for completeness, what about some front-end code? Well, it's just Gleam code again. We're beginning to see more of this. But here we import Lustre. So Lustre is a web framework. You import a bunch of stuff. So here we have, so for any of you who might be familiar with the Elm architecture, you start your app. This hash app is the element you want to bind it to in the DOM. You have to pass in an init, an update, and a view function. And those look like an init, an update, and a view function. So this is the Elm architecture in action. The message type is parameterized to be the same, so you can't start a Lustre app with the wrong view function and an update function. The model type in the update and the view will be type checked to be the same thing. So yeah, so again, we won't show you the error message, but if you try to run this on Erlang, it won't work, because Lustre has a bunch of bindings to DOM APIs. Again, if you have like utility code, it works in both places. So yeah, so in many ways, I think this is a lot of the power of Gleam that I want to sort of like why I'm excited about the type system. Gleam has moved a bunch of things which are kind of baked in Erlang to be library constraints, and then you use the type system to find out what you've got. It can really drive your development. It can encourage you to not depend on libraries that work in only one place if you want a certain reusability, or you can lean into it and be like, OK, this part of the program needs promises because we need to keep the UI thread unblocked. All right, so here we go. So now we're back round to this list. And here we go. And so here I've put down, so I've also put a star next to tooling and just kind of hope that you'll ignore that, because I haven't explained that it's great. But the error messages are good. So we've seen a few error messages, and we like them. It's very helpful. But I think the power of the type system really comes down to this API design, because a stable Erlang system has a lot of abilities to handle errors. But the ability to change quickly, move across environments, and really drive your design with the types is, I think, a lot of the value. OK, so where are we going with this next? All right, so here we go. Here's some more quotes. I got all of these quotes within, I think, a 1-week period on the Gleam Discord. So I haven't had to go back for ages to look for them. But I think this is a real power for what Gleam can bring to kind of the BEAM community. You can go up through it. Like, you can pick up Gleam. You can write it to do web app. You can make an internal dashboard. You can make a Lambda function. You can find out about OTP later. There's a bunch of people who go, where was it? I came to BEAM via Gleam, and I started checking out Elixir because of the Soul of Erlang Elixir talk. It's really powerful, what we have. There's a quote here from Haley, who is sitting in the room, which is, BEAM and Beamers have just been kind of quietly getting real shit done for literally decades. Like, no one doubts that the BEAM is really effective, but there's a sort of, I don't even know if there's an issue with the branding. It's just we've really lent into the hard stuff. Like sometimes it isn't. Okay, and so this is, I had to share this. We've had our 1.0 release. So these are, so blue is Erlang, Erlang's history on GitHub. Obviously, Erlang has a long history before it ever went on GitHub, so that's probably a bit disingenuous. Elixir is yellow, and then Gleam is over here. But our morning's keynote was all about the community. Like, we've got to be part of a bigger world. And I think like Gleam is really championing that. Like Gleam is taking, is being known in other audiences, and people from like the Elm ecosystem are going, oh, a Gen server, it's like the Elm architecture, and you're like, I hadn't seen that, but maybe. So yeah, so I think there's something happening here. I think if you want to like get involved with libraries, now's the time to do it. If you want to be indie and try it out, it's too late. It's already gone. It's mainstream. So, but yeah, so that's me, and that's why I think Gleam is exciting. Yeah, and I'm Crowd Hailer on the internet if you want to find me. Yeah. Cool.
Thank you, Peter. Do we have questions? Sure.
Thank you. Just was wondering about the claim. What's the meaning of this one? What's the definition you find the name claim or clean, something like that? Gleam.
Gleam, well, I mean, Gleam just kind of means like shiny, and it sounds like beam. So I think that's all it is. I mean, it's chosen pink and a nice star logo just to be friendly. I think I didn't want to like be mean to the Erlang homepage, but you can tell a difference of design styles where they've come from.
Lucas did everything, didn't he show that earlier?
Yeah.
More questions? If not, we are going to go to a coffee break. The QR code has been updated, I hear, and it looks like it's the right one. So it will hopefully stay up for a while. Go in, put one word answer about what you think.